The position of it helps us with position of the uterus. The uterus can have variable positions in the pelvis, and this can become problematic when we're scanning. So we use this cervix to guide us into the endometrial cavity, and then we can establish whether there is some degree of obliquity to the uterus. We can see, is it tilted, is it rotated? So let's look a little closer at how our beam works with this kind of uterus. This is the standard sagittal scan through the uterus. Now, if we have a tilting to one side or the other, we keep our beam in a longitudinal plane down the middle. We would have followed it through the cervix into the endometrial cavity, and we realize that the longest length of the longest axis is tilted from midline. It can also be obliqued and rotated. Sometimes the uterus is obliqued, so to get its longest axis, we have to actually rotate the beam. Now notice where I have this black dot. This black dot means that it's the top of the ultrasound beam. Okay, so as we come in sagittally, this is the top of the beam. And in order to find this uterus, which was actually rotated and obliqued, we had to turn so that the top of the beam is here. And in order to then that's its longitudinal axis, but to get its coronal axis, we have to keep rotating the probe counterclockwise 90 degrees, which ends up way down there in order to get our coronal view of the uterus. It would be very hard to understand this if you didn't think of how your beam is positioned, how the cervix helps you and leads you into the center portion of the uterus. So here's an example. This uterus was rotated and obliqued and tilted, and the person scanning had no idea what was going on and just took some kind of endometrial measurement. Well, what had happened was, had you followed the protocol, get your longest axis of the uterus, then rotate 90 degrees, one could measure the endometrium correctly. The endometrium should have been measured on a 90-degree plane from this. The uterus can be anteverted, usually. It could be in the mid portion of the pelvis, or it could be retroverted. And we have to understand the position so we can place masses correctly, place fibroids correctly in such a plane. So here's the standard view. This is sagittal. This is anterior, so this is the anterior wall, rotated 90 degrees. Let's look at that again. This is the anterior wall of the body, but this is the anterior wall of the patient's uterus. This is the posterior wall of the uterus. We know that the fundus is pointing towards the anterior of the patient's body, but the anterior anatomic wall is here. Notice that the anterior wall closest to the beam is on the upside of the picture, right? The beam hits the anterior wall first. Anterior wall is closest to the origin of the beam. The uterus has somewhat of a donut shape, has an endometrium located centrally. Now look at this uterus. It's a mid-position uterus. Here, it points down. It's parallel to our beam. And when we turn 90 degrees, we actually get a true coronal frontal cut of the uterus. So this is a mid-position uterus. Nowhere near does it look like the anteverted uterus. Turn 90 degrees, send a coronal beam through the uterus and you get a coronal shot. But both of these uteruses are parallel to the beam, which means we're not going to get as good resolution. So here's the example. This is the sagittal longitudinal beam. Notice a lot of dropout. Notice that there's an IUD, but we can hardly see its position. It's because this kind of uterus is parallel to the beam. When we turn 90 degrees, we don't do much better. We still don't see very well because it's still parallel, and we hardly see that IUD. That's the mid-pelvis uterus. Now the retroverted uterus, okay, this is the flipped back uterus. Watch where the walls are. The anterior wall of the uterus is here. The anterior wall ends up being deep in the pelvis, so that the beam hits posterior wall. Anterior wall is in the deep part of the pelvis, opposite from the anteverted uterus. So this is anterior wall, this is posterior wall. Let's do that again. Beam strikes posterior wall, anterior wall. Beam strikes posterior wall, anterior wall. This is the anatomic anterior wall of the uterus. So when you see a cross-section of a uterus like this and it has a fibroid on it, you should not jump to conclusions that this is a posterior fibroid. Because the answer here to this question, which wall is the fibroid on, the answer is, well, it depends on the position of the uterus. If this is a retroverted uterus, then this deep fibroid is on the anterior wall. If this is an anteverted uterus, then it will be on the posterior wall. So we have to know the position of the uterus. So here it is with the fibroid. Retroverted uterus has a fibroid on the anterior wall, so that ends up to be deep in the pelvis. The anterior wall is deep, so the fibroid registers deep in the pelvis. Okay, let's do that again here. The beam hits posterior wall. Anterior wall is the deep part of the pelvis.